Cool. Thank you, Melissa. And that was her polite way of saying I'm an old dude, in that historical knowledge. So yes, I'm Dave McAllister. I'm an open source technologist here at Nginx, which is part of F5. Some of y'all probably have heard a little bit about Nginx. We're fairly well known in the open source world, but today I want to talk about something a little bit different, and that's around this distributed trace. And by the way, I love the theme. So if you notice, I'd like to introduce you to one of my cats, Julia here. I am owned by 4 cats. I am completely used to being ignored. So this. But to talk about distributed traces, we have to talk about some things that are important. And one of them is why. Well, we start off with the concept that basically we're doing this for this thing called observability. And observability is things that now let us look inside of our application space, especially as it gets more complex, so that we can figure out the best ways to fix it up when it's not acting right for that. And in general, there are lots of observability signals, and these were the 3 principles. I think the number's up to 6 or something. I saw a new acronym called TIMPLE appear recently for talking about observability signals. But observability signals really break down into these 3 categories, none of which are brand new. They've actually been around for quite some time here. Metrics do have a problem. This is the number side of the house here. Logs, why is that problem happening? What does the application think is going on at any particular time? And then finally, traces, which is sort of the new member here. Where is the specific problem? So you can think of this as metrics for detect, traces for troubleshoot, logs to give me the root cause, the ultimate source of truth in here. And basically, it gives us the visibility into the state of the system, while at the same time giving us this reduced mean time to clue, and in terms, reduced mean time to resolution. So monitoring, which is an overlap for observability, basically keeps the eyes on things that we know can go wrong. We know that we might run out of memory. We know that we might run out of disk space. Observability lets us detect things that we didn't expect and help us explain why they went wrong so that we can move them into that monitoring category. Short, dirty point, why does anyone care about this observability? And the answer is microservices. Almost all of our applications these days are built out of lots of loosely coupled, independently deployed smaller services. They're often in different languages. They are very maintainable, very testable, because we can test each section independently and we can deploy them independently. The problem is they're not all owned by the same team. They can be widespread across this. They're often in cloud environments. And because of that, the microservices add some unique challenges to our space. Basically, anyone in mathematics knows you only change one variable at a time here. Well, when we take microservices and put them into the cloud, we've changed 2 variables at a minimum here. We've added microservices, which gives us a much more complicated model for this loosely coupled intercommunication practice. At the same time, we've added cloud, elasticity, and ephemeral behavior. This means that we have 2 intersecting things changing. Therefore, failures may not repeat. And debugging multi-tenancy can be painful. Generally speaking, and we're going to cover this a little deeper, we're talking about a lot of data. And so when we think about this, we have to think about how we move past that complicated model, that chaotic model, into this emergent practices. And that's where observability comes into play. So you're looking at what's called the Cynefin framework. It's one of my best descriptions for how we deal with things that are changing in multiple directions. And so I use this quite often. So basically, tracing is a data problem. You can think of this as tracing is going to tell you what's going on with each of those pieces. Tracing tracks an independent request as it flows through the system, from where you decided to start all the way through to its conclusion, whether it's successful or not. And that gives us the ability to have actionable insights based on the application experience or the user experience, depending on what portion we're looking at. And it also adds more metrics that are very important to us when we're looking at the best ways to approach making new things work So what you're looking at here is a somewhat sped up red monitoring chart. Red states for rate, duration, rate, error, and duration. And as you can see here, I've sped this up, but I was looking at somewhere around 14 to 20 requests coming through per second. The average latency in this case is somewhere around 280. And my error rate goes from nominal all the way up to 21%, I believe is the high end. I'm also seeing a strip chart approach. So I'm actually seeing the data as it comes into the system. Keep in mind that tracing is an individual piece of information. Every single request is a trace, and that trace can be done. But data is only useful, in a sense, when we can aggregate it, analyze it, and then generally visualize it. And so those things give us the ability to look at new alerts, new debugging, and give us that faster time to clue and to response. But it's lots of different models that can come into play around a tracing functionality. We can have RUM, real user monitoring, actually tracing the behavior of a user through the system from start to finish. We can have synthetics, which do a similar thing, but use a known trace, a known structure, so that we can now compare across upgrades or deployments. We can actually start comparing the changes in our behavior from a user viewpoint because we're using something that we've already baselined out. We can have network performance monitoring, how the network performs across a trace. Keep in mind that we are usually talking about a remote system, a browser, to a backend system through a loosely coupled network of application of microservices. And so network performance becomes incredibly important inside of that. We can have application performance monitoring, showing us basically what the back end is doing at any particular time. And then underlying all these things, because as much as we'd like to think so, we still have to have infrastructure that we run on. And so each of these things is driven by an observability signal. RUM, synthetics, network performance, and APM actually make heavy use of tracing behavior. And so tracing behavior drives the way we now look at the application model. So anyway, why we are looking at this. This is what it's really all about. So there are tracing concepts, but the tracing concepts are pretty simple. Let's start with the basic item of work, a span. A span is the discrete unit of work in your system. And that can be an application, a microservice itself, or it can be a portion of the microservice. So each of these pieces can be defined as a unit of work. The trace is all the spans for a specific request all together. And that trace is unique inside of your system. There is only one and only one trace that matches to those pieces. And then you can also add to it other things, distributed context, where it's coming from, what tags you want to add to it so that people downstream can understand better what the structure is and what the underlying pieces look like. You can also add options, things that you want to have carried over across each of those pieces. So let's take a look at a trace. And this is an acyclic, a directed acyclic graph. And it's a standard way of looking at trace behavior. In this case, I'm looking at the trace behavior going through the system of microservices. And each of these pieces adds specific information. So in this particular case, each of my little circles is a microservice or the service application. And you've got inside of that how long the application itself took. Each of those pieces will tell me. This is actually not showing an individual trace, it's actually showing an aggregate viewpoint for that. I'm also seeing the pathway where each service sends its next step. You've got a piece of work, that span. Where does the next span go to? And as you can tell, each of these pieces goes to a different microservice, sometimes multiple microservices, and each of those communication pathways also has an amount of time that it has to deal with. And so in this case, API sending off to catalog takes 72 milliseconds, sending off to, I think the order form is 212 milliseconds. And you can see each of the pieces as they go out. Inside of this, depending on the visualization model, you may get additional information. You may get error rates, or you may get size of connectivity, how much data is flowing through it. Visualization is kind of left and is completely separate than the creation and formation of the trace data itself. So once we're in a trace, we can visualize it in lots of different ways. We can massage it. We can deal with all sorts of interesting statistical approaches. So this is one of the ways of doing this. And this will clearly show you the pathway and the connectivity between the pathways, especially when it's multiple elements. Now, the next side of that, and the other side you'll see, is a standard trace waterfall plot. And the trace waterfall plot starts with, if you will, the trace itself being called. What's the top level environment? And that is the piece that has to extend until the complete work structure ends, times out, or receives an error. Underneath of that, you will see broken down. You'll see the spans, and inside of those spans, you will see also additional item of work where they are being called out. And so in this case, we can look at this and say API called off to the HTTP request, which called to the catalog, which called to the authorization. The authorization return came back and went back through this. And we can see how long that took, in this case, roughly 33 milliseconds. At that point in time, we were authorized and went to the next step for this, which is starting to look at the catalog, because it now knows that the person is the right person. And those two major spans, so have children's spans. So the trace has a span. Those spans can have subspans underneath of them. And the two traces them together add up pretty closely. That's about 2 milliseconds off from that point. You can also take that same trace data and look at it and say, how much time was spent in the application, how much time was spent in a database, how much time was spent on the network. And each of these pieces will give you additional information specific to where your activity is happening and where your time is being spent. Now, how does that magically work? Well, it's this thing called baggage. And observability, in particularly the tracing side, includes this thing called baggage. And baggage is contextual information that's passed between spans. Consider it a key value store that resides along with a span context that makes values available to any span created within that trace. And it uses the thing called content propagation, passes baggage around. Content propagation basically makes sure that you are in a safe store place to do that. Word of caution, baggage should be used only with data that you are okay with potentially exposing to somebody who looks at your network traffic. It's stored in HTTP headers alongside the current context. So it's not a protected environment. It's not an encrypted environment outside of the pieces that can't be seen. There is no integrity checks to make sure that the baggage items you're getting are the baggage items that you are yours. And so you have to make sure that you're getting the right baggage concept. So with that, that's a very quick viewpoint of what tracing looks like. Well, even though this is a very complex world, it puts out a ton of data here. It's really useful. So what do we need to make this tracing stuff work? Well, each trace has to be unique. You cannot duplicate trace IDs. And you have to be able to propagate that trace ID through all of the span activities. So you have a trace ID, you have a span ID, and they have to flow together to make that happen. Once we have that, we have to bring the data together, this consolidation structure. So we bring the data together and ship it to the right places. We want it to be distributed environment capable. We're talking about cloud work here. We'd like it to be standards based. So agents are good, cloud integration is good. And in personal case, closer to open source, the happier I am about this. We'd also like to make it as easy as possible. An automated code instrumentation, because we have to put the instrumentation around tracing into our application for that. And bottom line is we want any code at any time. So the first concept of this is APIs. And there's actually a very simple set of APIs that go into every one of these. Every language has to support each of these concepts. The first one is the trace provider. We get a trace point. It's access to tracers. It sets up the global provider. It can set up others, but it's the thing that actually lets us talk to traces. And then the tracer creates the spans. It creates that unique concept, and it delegates getting the active span, and marking a given span is active to that content propagation system. So that span information gets passed correctly and context gets passed correctly. And the span is simply the piece that traces the specific operation. Keep in mind that you can actually trace just between applications. You don't necessarily have to trace within an application as well. So when we enable this, pretty straightforward. There's two basic options, and I just kind of mentioned one of them. Service and traffic inspection. Traffic inspection lets us think of it as a service mesh, lets us look at how the request is being passed from service to service. And so we can look at how long it's taking to get from a service to a service, as well as how long it's spent inside of a service. What we don't get is what happened within that service. And so it's a set of information that will show us the behavior of our products, and it will show us, highlight the spots where we may be having problems, but it won't give you a really tight, detailed within that application or that microservices app itself. Code instrumentation is the next piece. And code instrumentation actually gets into the code and adds the specific information that you want to trace the behavior, the units of work within that microservices application or larger application. This is not limited to microservices, even though we tend to talk about it in that way. But when we start doing this, we have to do certain behaviors. We have to focus on the code, which means that we have to have the code, the license, the language of interest, all those different pieces. And we need to focus on the different pieces that are important to us. And so focusing on the code side here, you add the client library. And I think if memory serves me correctly, currently we support about 11 libraries as native libraries for OpenTelemetry for that. In tracing, there's only one that is not considered to be stable. In other words, ready for production for that. Once we've done this, we want to make sure that our library is in place. We focus on the service-to-service communications, and then we can add the things that we want to add. For instance, we did a piece on adding OpenTelemetry to a microservices application after the fact, production level service. And we found that it was really useful to tag the trace ID into our log IDs and tag the trace ID into our SQL calls. So each of those pieces gives you additional capabilities and additional information that's important. So what this basically means for traces: you instantiate the tracer, you create the spans of interest, you enhance your spans, and you configure your SDK. This is where life can be a little bit interesting. There is this thing called auto instrumentation, automatic. Just add the appropriate files. If you've got Java, you can just add the Java instrumentation directly to it, and you will get all sorts of tracing data coming out. It is very language dependent. Not all languages have this, and some of them you will have to go in and actually do coding for. If you're doing the manual side, import the API and SDK, configure the API and SDK, create your traces, and it's very straightforward, but you will need to go and change the code, create the metrics of interest. Again, if you want red, make sure you're getting that, and then send your data, export the data that's being created to the right place. You can use automatic and manual at the same time. What you can't do is use two different automatic interpretations at the same time. That will give you some really strange results. Automatic, your results may vary wildly, and you may actually not get what you expect you're going to get, and you may get a lot of data, and that data itself may be challenging to figure out what it's actually trying to tell you. But your apps have to be instrumented to get the correct observability signal. If you keep a quick flashback outside of traces, logs, and metrics, you're probably already instrumented for logs and traces, or logs and metrics. Here you're adding traces to that structure. So what are you trying to solve? Well, if you're looking at things like performance issues, if something is running too slow, traces are amazingly good at helping you understand what and why, as well as where things are running slow here. So are you having problems with time to resolution or time to detection? Well, traces, because it is looking at each request independently, can help you determine when things are sliding out of line for this. And then, as I mentioned before, sometimes it's kind of nice to know, particularly in a microservices ephemeral environment, where things are happening. So metrics are great for numbers and alerts. Logs give us what the application does, but traces let us know where something happened. And so adding traces to our metrics and logs provides us this context about where in our structure things are happening. And bottom line, the more data you have, generally speaking, the better your answers. But do you really need all of that data? So you can either have a span for every single thing, or you can have a bare minimum. So again, you could come back and go, I'm just going to deal with it from point A to point B. I want to know how long things took between it. Or I can deal with it and say, I want to know every time a specific unit of work or an event has occurred inside of the application space as well as inside of the environmental space. Generally speaking, it's best to start with your service boundaries and third-party calls. So understanding, again, how long the propagation happens between the services, as well as how long things took overall without going into each application space. This is really useful. The nice thing is you can treat this as an iterative process, which means you can build minimal and then add to it as you discover things that you're interested in. That means that you can constantly upgrade and improve your observability using traces to get specifically the things that you would like. The bottom line is you really have to be careful about information overload. This adds a lot of data. Think of it this way. A trace is like a log file. That log file, that log entry itself now has anywhere from one span to potentially hundreds of spans. And so your data overload for coming from a trace can be pretty massive. Make sure that you're getting the right data you need without having to necessarily get every piece of data. As an example, a former customer, previous company, for that was creating 43 terabytes of log files an hour. Fairly large cloud and type environment, you might say. They added traces to this and they basically turned on everything. And that number went to 92 terabytes per hour. No one can absorb that much data. And in fact, it's even hard to visualize that data in a meaningful way. So beware of information overload and keep in mind that sampling is not the answer to information overload, because sampling is simply reducing the amount of information you may be seeing, but not necessarily giving you the correct information. So distributed tracing gives you insights into its application and to its infrastructure here, but it requires effort. You have to be able to build something. The thing is, you don't see a win until the project is basically instrumented. And so that work aspect can vary from automatic to manual, can vary across a service mesh, but it is really useful once it happens. And there is a startup process that can go across that. Tracing is this great thing for user happiness. It's a proxy for understanding what your users are doing. But tracing does not magically solve any of the issues you may be happening. You are still going to have to deal with those pieces. And in fact, my favorite quote, the most effective debugging tool is still careful thought. coupled with judiciously placed print statements. Distributed traces are our new print statements. Brian Kernighan said this for Unix and beginners in 1979, and it's still just as valid here on October 31st, 2023. We are required to think about the data that's being given to us, as well as the places that we can make use of that data to improve our applications and our users' experience. And with that, I'd like to thank you for listening. I'd like to thanks for coming out on Spooky DevOps Day. And if you need to get a hold of me, I'm Dave Mack on LinkedIn. My slides are all available on GitHub, DW McAllister on GitHub. And you can always find me on Nginx Community Slack. And with that, thanks. And I will hand it back over to Melissa here.
Awesome. Thank you so much, Dave. Your presentations are just packed full of information. So I'm very happy that you shared your slides. I'm sure there are many in the audience that are going to be looking at those later. Something you said struck me just at the end there, just that you have to be thoughtful. And I do remember in the early days of my career where print statements were all I had to hang on to. That at least that's what I used until I learned better tools, of course. But it seems like we should probably be thinking more about, in order to take advantage of just the benefits of observability in general, we probably should be developing with that in mind right away, right? Like,
yes.
maybe not try to put it on at the very end. Maybe we need to start rearranging our thinking and starting with it first.
Absolutely. If you can, build it in from scratch. And that's actually where the most successful observability exists today. We at Nginx took this banking application, which exists microservices based, and basically said, what's it going to take to add OpenTelemetry to it? And we regretted our lives for about 6 months. When you think about architecting, you as an architect should know where the units of work and how they plug together. When you just built the application, what happens is people don't actually think about units of work and how they put together. And so it just magically happens. And so tracing, if you build it, when you do this, you'll have this great roadmap for what's going on in your app. And it's a lot easier to build a greenfield application than to try to go in and dig up the graveyard and add tracing to the corpses.
Right. So unfortunately, a lot of us are in this position trying to tack it on at the end. It sounds like you've had your experience doing that as well.
90% of the world.
As painful as it is, just because of how things are when you start, do you recommend OpenTelemetry? Is that something I could use today?
I actually recommend OpenTelemetry wildly, and it is incredibly successful. OpenTelemetry is used in so many production applications. Keep in mind that OpenTelemetry was the blend between OpenTracing and OpenCensus. OpenCensus came out of Google's experience for basically 5 years running production. And OpenTracing had been around by the time they merged together for, almost 8 years. And so both of them were heavily baked for tracing. When we added metrics and logs to it, the rules vary a little bit. And by the way, let me also add to this, languages matter. In tracing, it's pretty much stable. And you can use tracing pretty easily, with the exception of Rust. I think Rust is still in beta for tracing. Metrics, mostly stable, but there are some exceptions inside of that because we're coming out of strong metrics environments like Prometheus. And so we can use Prometheus metrics. Logs have just hit a stable definition. And so logs are a little more challenging right now to put into the overall picture. But OpenTelemetry is the choice. Everybody, all production applications that I know of, nobody uses anything that's not OTel-based these days.
You talked a little bit about auto instrumentation, and I can think of a few reasons why you might not want to go that direction instead. But I want to hear that. I want to hear from you and get some validation, my own thoughts there.
Yeah.
Why wouldn't we use that?
Yeah. So the problem is not that auto instrumentation doesn't give you really cool traces. The problem is that the amount of data it gives you is ridiculous, and it's probably not the data you want. So we'll use Java as an example. So you can just add the correct jar file to an application, and magically you will get traces. And the traces will be 150 spans long. And buried in that 150 spans might be two pieces of information you want to get, and nothing that, and that 150 spans, it's going to miss the 20 pieces of information that you really want. And so the nice thing about auto instrumentation is you can, cross my fingers, generally turn off things you don't want. But what you're going to do is auto instrument it, turn it on, go, oh my gosh, look at all this data. What am I supposed to do? And then go back in and start configuring and turning off the things you don't actually want. And then you're going to have to go in and manually add the things that you wanted to see that it didn't give you in the first place. So, when we did it for the Mara project, we found very quickly that we really wanted the trace to know what the database call was when it handed off to the database. The database was 80% of our time, and the database was 80% of our problems. So what trace was causing the problem? And so we had to go in and manually instrument so that when we saw a database call, it added the trace ID to it and logged it off for us. So, and by the way, some auto tracing tools are better than others, but Java is one of the ones that's the most complete. But this is where completeness may not be your friend.
Yeah, everything is not always better, right? It just sounds very familiar to some of the struggles I've had with even just logging when, starting there, even just trying to figure out what's going on with your system with just logging. And then finding out that, oh, we weren't so thoughtful about the type of logging, whether it was really important or what level the logging was on. So when we had to turn everything on, it was overwhelming information. And, we were in this business of shipping logs, so at least we had that part down. It was good. But the amount of information was incredible, which leads me to think that this is a similar problem with tracing. You can get too much information, right? I think you talked a little bit about that. Can you elaborate on that just a little more?
Okay. So I kind of stated this, sort of buried in this presentation. Remember that trace is an individual request. And in general, from a DevOps viewpoint, we're actually not too concerned about the individual request. We are concerned about the behavior of our system. I used to use it, and I threw up a little line about proxies, user proxies, user happiness proxies here. A user cares about their request right now, how long it took, and whether it was successful or failed. When we get into it from a DevOps viewpoint, we're concerned about the users, their cumulative request, and what the success and failure rate looks like. So if one user out of 10,000 has an error, we as DevOps may not really care unless it's repetitive, okay? That user cares a whole heck of a lot, just to let you know. A user really cares because his request didn't go through. So what can happen is we can start seeing behavior. We're seeing 15% failure rates across our user request environment. Let's go cumulatively look at those. The difference is tracing lets us actually group those things together and get the aggregate viewpoint. And so we can now start using exponential distribution models to start predicting where things are, or we can use Bayes' theorem. I do a talk on stats recently. Bayes' theorem to say, oh, things are going bad, it's probably the database. So a probability space comes into play. But otherwise, think about taking your average application, putting tail minus F on the log file, and tell me how much information you get scrolling across your screen. That's what tracing as independent viewpoints can do. And that's why we have to aggregate so that we humans can actually understand something that's going on and what the trends look like.
Yeah, that can be really overwhelming. So with all, getting all of this data, can you give me an example more of how we would know that users are okay? Like what's a good example of some tracing we'd want to pay attention to?
Okay, so there again, you think of it from the end user viewpoint, and it's how long it took. And so I'm going to start with that one. Generally speaking, and Google did I don't know if they've done it this year or not, but every 2 years they did a study that says how long is a person willing to wait for a request across the internet to complete? And the answer is 3.7 seconds. At 3.7 seconds, you're likely to have the person leave your site, especially in an e-commerce environment. They'll abandon their carts. They don't care anymore. 3.7 seconds. So if you start seeing requests regularly cross 3.7 seconds and your e-commerce, you have a lost sale. And so start looking at it from that view. The other side is using something like synthetic monitoring. So synthetic monitoring says, I have a request I'm going to throw in the system, and I know how long it should take. It's going to take 158 milliseconds, start to finish. And you do a new deployment, and all of a sudden that 158 milliseconds goes up to 1.5 seconds. Okay, that's another red flag that you can look for. That's an individual trace result. So aggregation, look for the outliers that are crossing your boundaries of interest. If you're looking at a user, 3.7 seconds is a long time, by the way, on the internet. Maybe look for something that if it's taking you more than 2 seconds, figure out why for that.
It's amazing how much our patience has changed over the years, right? That number just goes down and down, doesn't it? We used to be.
Well, again, we used to have this thing called Woodpecker, which the old terminal models, somebody would type their command in and hit the return key, and the system would go off and think about it and would come back. And the person would hit the return key again, and then it didn't come back. And then end up hitting the return key, and we used to call it woodpeckers because they do this with the return key like this. And then the system would respond to it and see 128 returns, and it would scroll off the screen. And so they'd have to start all over.
Nice. Yep. I think I've been guilty of that myself, I'm sure. Okay, this is a very selfish question because you're with Nginx. I use Nginx and have in the past a lot and a lot of different projects. Is it instrumented for tracing?
So what we did is recently built what's called the Nginx Open Telemetry module, open source functionality. There's also a community module. The community module will show you what's going on with Nginx. The Nginx model shows you the behavior of your request through the Nginx system. And so we actually found when we went out and talked to our users, because we're open source as well as commercial things, we don't talk to the users. The users want to know what the behavior is through our system, not what our system is doing. So the Nginx OTel module was designed to literally trace the behavior of the request coming through the Nginx system and attach it into your trace functionality. You can find it on GitHub under Nginx Inc. Look for just do a search for OTel and it'll show up. And we would love to get your feedback on it.
Awesome. Good to know.